Hello everyone, I am Tomal Bhor and I welcome you to today's video. Today I will discuss quadratic equation. This is a very important topic. So we will start with the definition. So what is quadratic equation? A quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers. And one condition has to satisfy that a not is equal to 0. Why this condition is important? Suppose if a is equal to 0, so what will happen? This part will become 0. So you are left with bx plus c is equal to 0. So this is not a quadratic equation. This is a linear equation. That's why this condition is very important. So I'm taking one example. X square minus 9x plus 20 is equal to 0. Here a value is 1 as the coefficient of x square is 1. B value is minus 9. Why minus 9? Because if you see in the general equation, you have to take positive plus b. So we can write this term like this, and the b value is minus 9 and the c value is 20 here. Okay. So next we will discuss the solution. So we will discuss the three type of three method to get the solution of a quadratic equation. First, I will discuss the factorization method. Second, I will discuss the completing the square method, and third, I will discuss the quadratic formula method. So one by one, let's start. First is factorization. So I am taking one example to understood the process. 2x square minus 5x plus 3 is equal to 0. Here a value is 2, v value is minus 5 and c value is 3. So how to get the solution? So first what I will do, I will multiply the coefficient of x square with the constant term, 2 into 3. Okay. As they are already in the prime factorization, you can't factor more. So this is a clue. With the help of this clue, you have to split the middle term. So let's split it. 2x square minus, I'm writing 5 as 3 plus 2x. How I am writing 3 plus 2? With the help of this. Now let's solve it further. So 2x square minus 3x minus 2x plus 3 is equal to 0. Now here you can see from the first two, what is common? X is common. So let's take x common. So you are getting 2x minus 3. And from the next to what we should take common, I will take minus 1 common. Why I am taking minus 1 common? So that this part will become, these two part will become equal. I am taking minus 1 common. So it becomes 2x minus 3. So you can see these two are equal. That's why I have taken minus 1 common. Now these two are equal. So that is you are getting 2x minus 3, x minus 1 is equal to 0. Now, as we know, if the product of two number is 0, so that suppose A and B two number are there, their product is 0, then one has to be 0. If you product two non-zero number, their product can't be 0. So one has to be 0. But the problem is we don't know which one is 0, like previously. So basically what we take either A is equal to 0 or B is equal to 0. So same approach we will do here, that as these two are non-zero numbers. Okay, as these two are non-zero numbers, so first take this one is equal to 0. So 2x minus 3 is equal to 0. So that implies 2x is equal to 3. That implies x is equal to 3 by 2. This is first solution. Or take the second solution, x minus 1 is equal to 0. So that implies x is equal to 1. So these are the two solutions. So next we will learn the completing the square method. So for that also I am taking one example. This example, 9x square minus 15x plus 6 is equal to 0. Okay. So now we knew one formula that a plus b whole square is equal to a square plus 2ab plus b square. This is a famous well-known formula. So we will try to convert this quadratic equation into this formula to get the solution. So I'm doing it. So now 9x square can be written as 3x whole square. Okay. And this 15 can be written as minus 3 into 5x plus 6. Right. Now, suppose this 3x square is the a value, a square. Okay. Now, what you need? 2ab. Now, this is the a value. Okay. 3x. Okay. So, 3x is the a value. Okay. And suppose this 5 is the v value. Suppose. Then you need a 2, na? You need it because for the 2ab. So, I am adjusting a 2. As I am like multiplying 2, so I have to adjust it. So, I am dividing it by 5. Okay. Because as it is the a value. So now this 5 by 2 is the b value. Now 5 by 2 is not there. So I have to adjust it again by giving a 5 by 2 here and subtracting it. And minus 6 is there. Okay. So now this is the a plus b whole square formula. So let apply it. So that is you are getting 3x minus 5 by 2 whole square. And this minus 5 by 2 whole square is nothing but 25 by 4 and minus 6 is equal to 0. So basically you are getting 3x minus 5 by 2 whole square. And if I do this, so this is minus 25 minus 24 by 6 is equal to 0. So I am getting 3x minus 5 by 2 whole square minus 1 by 4. This is 1 by 4 is equal to 0. Okay, so I'm doing it here, the remaining part. 3x minus 5 by 2 whole square is equal to 1 by 4. So if I remove the square, both sides, so what I'm getting, 3x minus 5 by 2 is equal to plus minus root 2. Okay, so I'm erasing a little this part to show you the calculation. Just 1 minute, let me just erase it. Okay. So first case is like take the first positive part is equal to this. Okay. So I need to find the x value. So what we can do, 3x is equal to 1 by 2. This is 5 by 2. So you are getting 6 by 2. Right. So this is nothing but 3. So that implies x is equal to 1. And if I do the another part is 3x minus 5 by 2 is minus half. That implies 3x is equal to minus half plus 5 by 2. So you are getting this is 4 by 2. So this is like 2. So x value is 2 by 3. So these are the two solutions for this quadratic equation. So let's learn the next method, the last method. Last is quadratic formula. So what is quadratic formula? Suppose you have a quadratic equation ax square plus bx plus c is equal to 0. So what is quadratic formula telling that x is equal to minus b plus minus root under b square minus 4ac by 2a. This is the quadratic formula. By this formula, you can get the solution easily. Like I am taking the well-known, like this equation I have already solved previously. So we have already knew what is the root is. So I'm just checking by the quadratic formula. The root I just found out a few minutes ago, is it correct or not? Let's check. So x is equal to minus b at b value is, you can see, minus 5. So minus of minus 5 plus minus root under b square. What is b value? Again minus 5. So minus 5 square minus 4 into a value is 2 into c value is 3. Okay, by 2a. 2a value is 2. So if I calculate this one, what you are getting here 5, here this is 25 and 4 times 2 is 8, 8 times 3 is 24. Sorry, this is 25 minus 24 by 4. So basically what you are getting, 5 plus minus 1 by 4. So so you are getting x is equal to, first is 6 by 4. So that is 3 by 2. Obviously this is correct. And next is you are getting minus, if you 4 by 4, you are getting 1. So both the solutions are correct, because in the previous like same problem we have done for this factorization, and we got the same answer. Okay. Last is nature of the root. What is nature of the root? Nature of the root. Suppose you are solving a quadratic equation. Now the root can be distinct. Distinct means you are getting two different values. Okay. But not every time you will get different. Like what example I have taken, every time I am getting different values. But sometimes you will get two values which is equal. And in some cases, what happens, you may not get a root. I mean, real root doesn't exist. But thing is, like, you have to solve the equation fully, then you will know that it is what type of roots are there. But without solving, there is a method you can tell that what type of roots are there. This is called the nature of root testing. So basically we just learned this quadratic formula, x is equal to minus b plus minus root under b square minus 4ac by 2a. Here this part, b square minus 4ac, this is called discriminant. Now by the nature, sorry, not equal to 0, so only b square minus 4ac, this part is called discriminant. By some condition, we will use some condition, and if those conditions satisfy with this particular b square minus 4ac, I can tell what type of roots are there. First is, if b square minus 4ac greater than 0, then I will say both the roots are distinct. If b square minus 4ac is equal to 0, so I will tell both the roots are equal. And if b square minus 4ac less than 0, then what I will tell, that they are not, I mean, there is no real root. Real root not exist. So let's take one by one example and see the cases. So first case, so take one example of this one. 2x squared minus 7x plus 3 is equal to 0. Now, if I take b square minus 4ac, what I am getting? B value is minus 7. So minus 7 square minus 4 value. A value is 2 and C value is 3. So what you are getting? Minus 7 square is 49. Minus 4 into 2 is 8. 8 into 3 is 24. So basically you are getting 25, which is greater than 0. So both here in this equation, quadratic equation, both the roots will be distinct. I mean, we will get two distinct values. Let's take the second case. For equal case, I am taking one example like this one. 3x squared minus 2x plus 1 by 3 is equal to 0. Here I am taking b square minus 4ac. Here v value is minus 2. So minus 2 square minus 4. A value is 3 and C value is 1 by 3. So this value will cancel. So basically you are getting, this is 4 minus 4, you are getting 0. So that's why here you will get both the root will be same. Let's take the last case. Last case is this one. 2x square minus 4x plus 3 is equal to 0. So here b square minus 4ac, what you are getting is equal to, that is minus 4 square. Okay, b square minus 4ac, 4 into a value is this and c value is this. So what we are getting, this is 16 minus 4 times 2 is 8, 8 times 3 is 24. So you are getting minus 8, which is less than 0. So here what you will get, here there is no real root. Okay, real root doesn't exist. So this is the nature of the root. So I hope you have enjoyed this video and you have learned something new. So this is the end of the demo video. Thank you, everyone.